I've often heard dance referred to as movement through space and time with energy. And these three concepts of space, time, and energy just happen to be concepts that are directly related to this concept of velocity that we're going to talk about in this video. So there's this neat little nexus, there's this neat little interaction between a scientific concept of velocity and this concept of dance as movement through space and time and energy that I hope you will enjoy as we go through this video. So in the previous video I described velocity as equaling being the derivative, and it's often referred to as the first derivative of displacement. And basically what that means is that we can derive velocity if we have displacement. We can determine velocity if we have displacement. So displacement deals with space, it's movement around in space. But velocity then needs this factor of time. So let's have a look at how we're going about deriving velocity. So in the previous video we considered our ballerina moving here from point 1 all the way through space to here in point 2. And if we looked at the length in between point 1 and point 2, we called it 3 meters to the right, just for the purposes of the video, and we called that 3 meters to the right displacement. So that is our space, that is the space that the dancer has moved through. Now if we also have measured the time that it took her to move through that space, and for today's purposes let's call it 1 second. If she has moved that 3 meters to the right in 1 second, your math brain might be ticking over now, and you can sort of appreciate that velocity, because it is the combination of space and time, we calculate it by saying, well, it's the displacement, which in this case is 3, divided by the time, which in this case is 1. So we would describe her velocity through this leap as being 3 meters per second. So basically our ballerina has moved through 3 meters in 1 second. She's moved at 3 meters per second. And it's no real different to the speedometer on your car, which may tell you how many kilometers per hour you're doing, or miles per hour that you're doing, depending on what part of the world you are based in. But really what that is giving you, what your speedometer is giving you, is this concept of speed. And speed is to velocity as distance is to displacement. So speed does not have a direction. It does not equal a direction. Whereas velocity does. It needs a direction. So we need to add our right here on the end. So velocity, 3 meters per second to the right. And that's about as simple as it is. Now, but what about this concept of energy? So that's space and time, but what about energy? Well, the neat thing about velocity is that if any object is moving and it has a velocity, it means it immediately has energy. So in order for an object to be moving around in space, it has to have some form of energy within it. It has to have an energy within it that is moving it around in space. And that energy comes from a force being applied to it. So energy is produced within a body if a force is applied to it. And that can come from a dancer's muscles, it can come from gravity, it can come from a reaction force, it can come from a combination of all of those forces, which is the most likely situation. So velocity really is movement through space and time because it has energy. And because a body has energy, that is allowing it to move through space and time. So in the next video, we're going to look at then the second derivative of displacement, which is acceleration, and really describes this connection between force and the movement through space and time.